Okay, this video is on infinite sums. So this worksheet that you're looking at here, you should have in your workbook. And most importantly, you should have completed what we call partial sums. So I'm not going to explain these parts right here because these parts right here are just you using the sum formulas to find what we call partial sums. So if you'll notice here on number 1, this circle here, this is an infinite series because it says plus dot 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 at the end. So I can't add up an infinite number of numbers, so these are partial sums. So here I added up the first 20, here the first 50, here the first 100, here the first 500. And what we're looking for is to see if the sums converge or diverge. Whereas last class we looked at whether the terms converge or diverge. So there's a difference. So again, in order to keep this video from being an hour long, this part here you should just have already done, or you're going to have to just believe the math that just comes from the formulas that we've already done. Okay? All right, so now let's just talk about summarizing. So this first one here is arithmetic. These are going up by 3. And you notice that the terms, or the sums, the partial sums just keep getting bigger. First it's 670, 3925, now it's at over 15,000, 376,000. So we would say that the more terms I add, the bigger the sum gets. And so we would say that the sums, this is the catch, the sums diverge. Means they don't approach a specific number. The only thing that they do is they do just keep getting bigger. And so since those sums just keep getting bigger, we would say that the infinite sum is infinity. Sometimes I write it like this, just S sub infinity equals infinity, because those numbers just keep getting bigger and bigger. Okay? If you look at this example number 2 here, okay, this is also arithmetic, but D in this case is negative. So you'll notice that these are going down by 8, down by 8, down by 8, down by 8. Okay, so here we are again. These are the partial sums. Okay, so S sub 20 is negative 1500. If you add up the first 50 numbers, it's negative 9750. Add up the first 100, negative 39,500. And add up the first 500, and it just keeps getting more negative. So these numbers are getting bigger, and they're still negative. Okay, so they're not approaching a specific number, so we say the sum diverges. Okay, so we would say S sub infinity equals, in this case, negative infinity. Those sums are just getting more and more negative. What you should notice in both of these arithmetic cases is that the terms are also diverging. So the terms in, let's just look at number 2. The terms are just getting more and more negative. So if we look here, the terms here are getting more and more negative. So it makes sense that the sum would also, the infinite sum would also just continue to get more and more negative. So what happens to an infinite sum depends on what the terms do. Okay, all right, so let's take a look at 3. We're going to switch to geometric. So we've done all the possible cases of arithmetic. Arithmetic either has a positive D or a negative D, and the same thing is going to happen either way. If D is positive, it's going to eventually get to positive infinity in this case here. And if D is negative, it'll get to negative infinity at some point. But now let's take a look at geometric. So geometric is going to have 3 separate cases that we're going to look at. So case number 1 is when R is bigger than 1. Okay, so here in the case of number 3, here's my formula. So I can tell from the formula here that R is 2, and 2 is bigger than 1. If we think about what 2 does, this should double all of my numbers. Okay, so 3, then I double that to 6, double to 12, so on and so forth. And this is an infinite sum. Okay, so the terms in that series are just getting bigger, right? 3 doubles to 6, so on and so forth. So this right here is what the terms are doing. Okay, so the terms approach infinity. When we slide down to this next section, we want to know what the sums approach. So if I keep adding up more and more and more numbers, what do the sums approach? So this sum of just the first 10 is already at 3,000. The sum of the first 15 is over 98,000, and the sum of the first 20 is over 3 million. So I find that to be interesting. If you notice with geometric, I've only added 20 numbers and I'm already at 3 million. And that's because the doubling makes the numbers get really big really quick. Okay, but if the terms approach infinity, then it makes sense that the sum would approach infinity. So these terms diverge, and when the terms diverge, so will the sum. Okay, so in this case, the sum is diverging, but it is diverging to infinity. So we would say S sub infinity equals infinity, because that's what the terms are diverging to as well. So the opposite of that would be, what if R is less than -1? So we just did R is positive, or not positive, but greater than 1, and now it's less than -1. So here's my formula. Okay, I can tell that R is less than -1 because the base here is 3. So what this means, remember, is that the numbers, each number is going to get multiplied by -3 to get the next number, and so forth. Okay, so what we want to do is look at what these terms are doing. So here's the terms. The terms in that infinite series are getting bigger, but they're also alternating signs. So if I didn't have the negatives there, they would just be getting bigger and going towards infinity. But because my multiplier is negative, these numbers are getting bigger, but they're also flopping signs. So we would say, based upon last lesson, that these numbers diverge. Okay, actually, let me say that differently. The terms diverge. Okay, and in this case, they diverge, but they don't diverge to a specific thing because they're alternating back and forth. So we say that the terms, the limit as n approaches infinity of the terms just doesn't exist. Whereas up here, we said that that limit was infinity. It was diverging to infinity. These are not diverging to infinity. And what should eventually kind of hopefully start to ring a bell is that if the terms diverge, so does the sum, right? So if we look at these infinite sums, here is the sum of the first 10. It's negative 29,000-ish. The sum of the first 15 is positive now. 7 million. And the sum of the first 20 is negative now. So these sums are also alternating back and forth, just like the terms. So again, we would say that the sums diverge. But since these are alternating back from negative numbers to positive numbers to negative numbers, etc., this infinite sum doesn't exist. I can't tell you that it's infinity or that it's negative infinity because it depends on how far down the sequence I've gone, if the last number is going to be positive or negative. Okay, this is the most interesting case, okay, where R is between -1 and 1. So if we look in this example here, R is 1/2, okay, which is between -1 and 1. Here are my terms, right? I start at 8, and then I take half of 8 to get 4, and half of 4 to get 2, and so on and so forth. And this is still an infinite series, but this is what's most important here. The terms in that series are converging. So this is the first time. So we're on example number 5 here. And this is the first time that we can say the terms converge. Okay, and the terms in this case converge to 0. Right, these terms are getting smaller and smaller and smaller and smaller. And so the terms converge to 0. If the terms converge to 0, then you actually can find the sum. So take a look at these examples here. Here I added the first 10 numbers and I got 15.98. And then here I added the first 15 numbers and now I have 15.9995. And now here the first 20 numbers, 15.999. And I don't even know if it'll let us do 100, but let's see. This would be the first term times 1 minus r to the 100th over 1 minus r. I'm going to just type that into my calculator real quickly. 1 minus that times 8 divided by 1/2. Okay, so this is, it just actually says 16. It just rounds it up to 16 once I get to 100 terms. Now, it seems weird because these are only what we call partial sums. I'm not actually adding up an infinite number of numbers, but because these terms are converging to 0. Okay, sorry guys, somebody came into my office, so I have to remember what I was just saying. I know what I think I was saying. If the terms continue to get smaller and smaller and smaller and approach 0, then no matter how many terms I add, eventually what I'm adding each time is just another number that's even closer to 0. And adding a number that is closer and closer to 0 is not going to start changing my sum very much. That's why you don't see much of a change in all of these sums. Okay, so if the terms converge to 0, then we actually would say that the sums converge. There is going to eventually be a sum that you can find based upon that. And you can tell here these were all approaching 16. So I would say S sub infinity equals 16. Okay, now the little bit more complicated one to look at is this. So this is still R is between -1 and 1, but in this case R is a negative number, so I made it -1/3. So the terms are alternating back and forth, but they're getting smaller. And this we already talked about in class, but if you think about this, you know, this might be the first term is 9, now I'm at -3, now I'm at 1, now I'm at -1/3, +1/9, -1/27. So even though they're alternating back and forth, these terms are converging, right? These terms converge to 0. And if the terms converge to 0, that means I can find an infinite sum, because eventually way down here, when I keep adding these numbers, the numbers are so small that they're practically 0 and they're not going to change your sum anymore. So take a look here. S sub 10 is 6.749. S sub 15 is 6.75. This is 6.7499. And while this time it's a little bit less than 6.75, and this one's a little bit more than 6.75, that's because sometimes my number is tiny, tiny, but bigger than 0, and sometimes it's tiny, tiny, but less than 0. So we say the sums converge, and they converge to 6.75. So S sub infinity, in this case, would equal 6.75. Okay, so let's try. I don't know if there's any space. You might just write this down somewhere else, but we're going to just try to quickly summarize. So here's the thing that you're supposed to look for, okay, is what the terms do, okay? So if the terms approach 0, then S sub infinity exists, okay? And we'll talk about how to find it in just a second. Okay, so here's all the cases that we did. If it's infinite arithmetic, it always diverges. Okay, an infinite arithmetic is always going to diverge. If it's an infinite geometric where R is bigger than 1, so think about that as doubling, tripling, etc., it's always going to diverge. If it's R is less than -1, it's also always going to diverge. This is the only case right here where it can converge. When R is between -1 and 1, then the terms approach 0. And because the terms approach 0, S sub infinity is going to exist. Okay, so here's how you find it. It's not going to be a huge proof, but you'll get the idea. So this is our formula for finite geometric. Okay, the key piece is this part right here. Since n is approaching infinity, that fractional value, so let's just say for argument's sake that it's a half. Okay, if I take a half to a really big number, it should approach 0. If you're not sure or not convinced by that, type in a half to the 10th and then type in a half to the 100th and see what it gives you. When I type in a half to the 100th, it gives me 7.9 times 10 to the -31st power, which is pretty small. You'll reach a spot where you'll plug in a half. Let me see. I'm trying to figure out. If you plug in a half to the 500, it just tells you 0. So this term right here is going to approach 0 if R is a fraction. So what you would have next then would be T sub 1 times 1 minus 0 over 1 minus R. And 1 minus 0 is obviously just 1. So now you have T sub 1 over 1 minus R. that's how you find the sum of an infinite geometric series when r is between -1 and 1. So if for just a moment we roll back up here, okay, and try it for, say, this one right here, number 6. Okay, to find s sub infinity, that's t sub 1 over 1 minus r. Okay, so t sub 1 is 9 over 1 minus, and my r is -1/3. So that would be 9 over 4/3. And if we go with our fractions, that'd be 9 multiply by the reciprocal. That'd be 27/4, which is 6.75. Okay, the thing you cannot forget is that this formula only works if r is between -1 and 1, because in any of the other cases, the sum diverges. So before you start just using this formula for all infinite things, you have to determine if r is between -1 and 1. So this is what would happen here. Here's just a couple of examples, and then we'll be done. So here is an infinite series. I can tell it's infinite because it just says plus ... So I first need to determine what type of series it is. So I would start by seeing if it's arithmetic, but this is -4. But if I -4, again, I don't get this. So it's not arithmetic. To check for geometric, I would divide. So I'm going to divide 12 divided by 16, which is 0.75. Now I'm going to check 9 divided by 12, which is also 0.75. Okay, so this is geometric with r equals 0.75. So it doesn't look like it quite yet, but these numbers are getting smaller and smaller and smaller because my multiplier is less than 1. Right, this is between -1 and 1. So these terms are getting smaller. So the terms are approaching 0. And in that case, I can use this formula, t sub 1 over 1 minus r. So the first term is 16 over 1 minus 0.75. And that should come out to 64. And if you add the numbers up right now that you already have right there, you should already be getting close. They already add up to almost 44, and that's only 4 numbers. But eventually they're going to keep getting smaller and smaller and smaller and smaller, and therefore practically 0, and therefore this would be my infinite sum. Okay, let's see here. This looks like times 1/3. Okay, so this is geometric with r equal to 1/3. Since 1/3 is between -1 and 1, then I can use this formula, t sub 1 over 1 minus r. So for this one in particular, the first term is 1, and r is 1/3, so it'd be 1 over 1 minus 1/3, which would be 1 over 2/3, which would be multiplied by the reciprocal. So this infinite sum would be 3/2. And again, the reason I'm able to find the infinite sum is because the terms are getting smaller. 1/3, then I get smaller than that by dividing that by 3, dividing that by 3, dividing that by 3, and so my terms just keep getting smaller and smaller and smaller and smaller, and therefore practically 0. So when I start adding up an infinite number of numbers, it'll eventually approach a specific number because I'm basically adding nothing. And then let's just do this one here as the last one. So this one is arithmetic with d equal to +5. So an arithmetic series always diverges. Right? The terms are not getting smaller. There's no adding of 0, so it always diverges. So your infinite sum, you just have to reason through. You have to look at these numbers and say, it's just going up by 5 every single time. So these numbers are just getting bigger and bigger and bigger. And so my infinite sum is just going to be infinity.